Okay, here's a second example for you guys for graphing rational functions. First one didn't have a slant asymptote, so guess what this one does? We still start them the same way, right? We still start them the same way. I'm going to find out my y-intercept, right? Y-intercept, plugging 0 in for x, so 0 squared plus 0 minus 6 all over 0 minus 3. I get a negative 6 over negative 3, which is a positive 2. So my y-intercept is at 0, 2. I actually get one this time. Second is, do we have any holes in the graph? Do we have any holes in the graph? And again, we have to make sure that this is factored so we can see. I need two numbers that when I multiply them, I get a negative 6, and when I add them, I get a positive 1. Those two numbers are x plus 3 and x minus 2, or actually, those two numbers are positive 3 and negative 2, but then that factors. And of course, that's over x minus 3. Now, nothing is going to cancel, so there are no holes. Okay, so that's a big old nope. Number 3, right? Number 3, we had to do zeros. Okay, so zeros, I just take my numerator, set it equal to 0. I have an x plus 3 times an x minus 2. Set that equal to 0. So ultimately, I have zeros at x equals 3 and x equals a 2. I'm sorry, x equals a negative 3 and x equals a positive 2. So I'm definitely going to have zeros to graph. I'm going to scooch up to this little spot up here, and we will put vertical asymptotes right there. Okay, vertical asymptote, set your denominator equal to 0. So I will have a vertical asymptote at x equals 3. And of course, we have no slant asymptote. I'll just write it out for us. I'm sorry, no horizontal asymptote. Okay, horizontal asymptotes, no, because the degree of the numerator is bigger than the degree of the denominator. Okay, so there are none. Okay. Now, when I have no horizontal asymptote, I have to take this a step further because I want to see if there's a slant asymptote. Now remember, for a slant asymptote, the degree of the numerator has to be one more, exactly one more than the degree of the denominator, and that is the case here. So when we do this, time to do a little scrolling. When we do this, step number 6, let's go dark gray. So step number 6, right, the slant asymptote, we take our numerator and divide it into our denominator. So our numerator is an x minus 3. We are dividing it into an x squared plus x minus 6. Now remember, I don't care if you do long division or synthetic division, but you've got to be careful. You have to have your placeholders, right? So if I didn't have this x here, I'd have to make sure that I wrote a 0x for my placeholder. As it happens, I have a 1x there, so I don't have to worry about anything. Okay. Long division for polynomials is just like long division for numbers. You take a look at your first terms, right? X times what would give me the x squared? Well, x times the x is going to give me x squared. So I put an x right there. And then ultimately what I'm going to end up doing is basically distributing that to both of those. So when I distribute that to both of those, and I'm going to undo my arrows, x times x is x squared. X times a negative 3 is a negative 3x. And then I subtract like I would in long division. So x squared minus x squared, that's just a 0, and that's what we want. I have a 1x minus a negative 3x gives me a positive 4x. You bring your next number down, next number or item, whatever it is, and then you repeat your process. I'm now looking for what times x will give me 4x. Well, a 4 times an x will give me a 4x. So I write a plus 4 up here. And then again, it's almost like I'm distributing here. You have to basically multiply the 4 times those two items. Aw, really? All of that's gone. Okay. So 4 times x is a 4x. 4 times a negative 3 is a negative 12. Again, you're going to subtract. The reason that we want to make sure that we subtract here is we want to make sure that our actual x terms disappear. So 4x minus 4x, that's gone. Negative 6 minus a negative 12 gives me a positive 6. So that would be my remainder, but I don't actually care about my remainder right now because ultimately all I really needed was this right here. This is the equation of my slant asymptote. It's going to be y equals a 1x plus 4. So my slope is going to be a 1, right? And my intercept, my y-intercept, is going to be a positive 4. And I'm running out of room. There we go. Sort of. That says intercept. You know it does. So now all I have to do is, again, I'm going to sketch the graph of what I have, and then I'm going to go to my calculator and get the shape of my actual function. So when I'm scrolling back up to my graph, I made the graph a little bit smaller, guys. Sorry about that. I was trying to get everything in one spot. So starting at the top, we can start at the top. We got a y-intercept of 0, 2. So 0, 2. There's my y-intercept in red, just like my work. There are no holes in the graph, so I don't have to worry about anything else. I have zeros at -3 and +2, so they're in purple. There's my -3, and there's my +2. Right? And then I have, oh goodness, where am I at? Oh, nope. There I am, green. 4 for vertical asymptote. I've got a vertical asymptote at x equals +3, so just a vertical line right there. Right? And then I have no horizontal asymptote, so I don't have to worry about it. And my slant asymptote, remember, my slant asymptote was y equals 1x plus 4. That means I start at 4 on my y axis. So there's a 4, and I'm going to use dashes for this instead of points. And then my slope was 1 over 1, so I go up 1 over 1. And remember, your slant asymptote is always slanted. This is like not working out too well. I need a new smartboard pen. All right, there's my slant asymptote. Wow, that did not do well. Down 1 over 1, down, yeah, all right, it's kind of there. So then all I have to do now is I have this general information here that I found all through algebra, and I'm going to go with, and now use my technology. Now I'm going to look at my graph, and I'm going to bring up the shape of the graph. Now when you bring up the shape of the graph using your calculator, if you just do zoom 6, which is standard, the only thing that will show up is the one curve right here, and that's fine. Ultimately, what ends up happening is if you zoom out, so you would hit zoom 3 and then hit enter, you will see another curve up here as I'm drawing right there. I hope you can see the tiny little blue curve. You will see another one up there, but because we're dealing with a -10 to a +10 on our scale, I'm fine with just the big curve on the bottom, okay? So I hope that works. Let me give you a full screenshot of that so you guys have it. Hopefully, maybe. Yeah, there it goes. So you got everything there. And I hope that helps.